Hi everyone, thanks for coming today. I'm going to be trying something new and a little bit out of my comfort zone, aside from talking. I've got a ask for questions link, so if you go up there, you can submit some questions and I'll get to them at the end if we have time. I know we're all busy people and we've got lots of things to do, so I'm going to get right to it. Here's the checklist. Thank you, and I'll see you at the Agdas. Seriously though, I'm super excited to be here talking about shipping online services for your games. We'll come back to this checklist soon, and I've got a link at the end of the slide to this presentation with speaker's notes, so don't worry too much about writing it down because you can get a copy at the end. But first, I want to start with a bit of a happy story. I want you to imagine that you've just shipped your online game. Congratulations, it's super successful and very popular. Everything is going really well, but one night, a few weeks after you launch, as you're getting ready to go home for the day, your server environment begins to become unhealthy. Error rates are up and requests are taking longer. Luckily, you have a monitoring system with alerts set up, which lets you know that something isn't right. You pull up your monitoring tools, you start going through the logs, and it turns out that one of your endpoints has a null reference error. We've all been there. You quickly fix the error, redeploy, and verify that your environment is healthy again, shortly before heading home. So to recap, alerting brought the issues to our attention, monitoring and logs gave us visibility into the issue, our incident response plan informed how we acted, and our continuous integration and continuous deployment let us quickly and confidently deploy the fix. So that was a really happy outcome. We got to go home from work without being too late. And I want to walk you through what needs to be in place for this to be possible. So let's continue with continuous integration and deployment. Online services and infrastructure come with a lot of complexity, which can slow down development. It can slow down onboarding, and it can make your server side less accessible to your team, which in turn leads fewer people having the knowledge required to work on your game servers or online services, and adds a significant key person risk. Each of your developers might also have their own development environment. Your organization might have a staging environment for QA or test builds, and of course, a production environment that needs to be online and healthy at all times. And it's very easy for any of those environments to become inconsistent if you're manually deploying changes across all of them. Those inconsistencies can lead to code working in development or staging and then not working in production. If the environments are inconsistent, you can no longer confidently deploy to production without potentially risking bugs or downtime. So it's for all of those reasons that I believe that automation is key to running online games and online services. It's a central point that I will be coming back to throughout this talk. How do we deploy changes? Let's talk about automation. If you're not familiar with continuous integration, it's the practice of merging all developers' work into working copies into a shared trunk or master branch several times a day, and usually a build is started after each time that happens. We use continuous integration all the time to build our games, and most of you are probably aware of the benefits of using it. One of the biggest benefits in this context for online services and game servers is that smaller changes are inherently safer than big changes, as there are just fewer things that have been changed, so there's less that could go wrong. And if something does go wrong, you have a lot less code to go through to find the problem. So that's what continuous integration is, but we're going to take it one step further, and we're going to look at continuous deployment, which automatically deploys those changes. Deploying often encourages smaller changes that reduce your risk in the same way that continuous integration does. And automating the deployment process helps keep your environments consistent to give you confidence when deploying to production. It also keeps your server code accessible to your entire team. You don't have to set up a complicated environment on your workstation, and it's not a strict requirement to understand each step involved in the deployment process, although it's still good practice to ensure that that knowledge is shared. All you have to do is open a code file, make your change, commit, and then test in the game client once the automated deployment is complete. So it's super simple and it's really accessible. At least that's the aim when you're working with continuous deployment. Your game server code and environment should also be immutable once deployed. Anything that your server needs should be packaged and deployed together with that server. For example, you might be tempted to have an external configuration file that your server downloads at startup, but what happens if that external configuration file becomes unreachable or is unknowingly changed? How can you test the old server code with your new configuration changes? A much more robust way of handling that would be to package the configuration file in with your server code so that you can be confident that all your changes get tested and deployed consistently. All right, enough about why. Let's have a quick look at how. You are the best placed person to know what your organization needs and what your pipeline should be. So you need to take some time and do some research to pick the right one for your specific use case. But that being said, there are 2 CI tools that I've enjoyed using, which you might want to have a look at. The first is Jenkins, and it's not the right tool for every job, but it's very configurable, and it works pretty well when you have a lot of different build types. It does take a decent amount of effort and time to set up and maintain a Jenkins server though. And when backing up and restoring, it can be a bit of a pain point for you as well. June Rhodes suggested having a look at job DSL if you use Jenkins, because that can help keep it a little bit more in source control rather than being a separate entity to back up. The other tool that I've used is GitLab CI/CD, which in contrast is a lot more lightweight, and it uses configuration files that are checked into your repository so that changes are tracked right out of the box. And if you're looking for a more lightweight option, it's definitely worth considering, but it's going to be very specific to your workplace and your pipeline, so you need to do the research. So yeah, those are the 2 options that I'd say have a look at, but have a look for your own uses. For continuous deployment, if you're planning on having persistent servers using AWS or Azure or Google Cloud, or if you're looking at a self-hosted Kubernetes environment, I would definitely suggest having a look at Spinnaker. It's a little bit more technical, but it can be really powerful when you get it set up correctly. If you want something that's a little bit more light touch, then you might also want to look at Terraform or your own custom deployment scripts, depending on your situation. When picking continuous deployment tools, you should consider the type of server that you need to deploy to, because serverless versus your persistent servers versus a Kubernetes cluster is going to be different. And the provider that you are deploying to is also going to have to come into your decision. So take some time again and research the tool that's going to work the best for you. So now we're going to look at tests. Now that we have CI and CD in, we should have a look at how automated tests can fit into this picture. So your tests can be configured to run at build time, and they can stop the build if any tests fail. You can also set up your build failures to post to Slack or another alerting channel. I personally like unit tests, static code analysis, and linters when I'm working with servers. But choosing the right tests is a balancing act and an entire talk by itself. So you should use what your organization leans towards in terms of testing and make that decision for yourself. You can also run tests at deploy time as part of your deployment strategy. So there's no right or wrong answer, although I would say no deployment tests is probably the wrong answer. And it's also incredibly heavily dependent on what your continuous deployment tool offers. So Spinnaker uses blue-green tests and canary tests, for example, and AWS lets you use canary tests, I believe, as well with Elastic Beanstalk. So it just depends on what you're using to deploy. So to have a quick recap, now we're running tests, we're using continuous deployment to make small changes often, and we're leveraging automation as much as possible to save time and improve consistency. We're also thinking about immutable infrastructure, and it sounds like we're ready to have a look at monitoring and logs and alerting. So when you set up logs, there's a few different parts to consider. There's your log sources, which are application logging, directly related to your application. This is where you get exceptions or user X signed in or did Y action. Anything that your application logs out, basically. There's server logging, which might be your load balancers, log requests, request logs. It could be boot logs, it could be kernel logs, or other system level logs. Anything related to the operation that anything related to the operation of your server that isn't application logging, basically. You will also need a tool to collect, search, and view those logs. If you're using a cloud provider, this is usually really simple to set up, and there should be plenty of documentation on it. If you're self-hosted, a tool like Elasticstack or Splunk or Graylog could fulfill this role. There's a really, really large number of options out there for log collection, aggregation, and searching. So again, you should do some research and pick the one that's right for you. And those tools change over time as well. So what could be really good today could be worth changing over in a year or two from now, kind of thing. Performance monitoring is related to your system usage. So it might be CPU, RAM, or disk usage, but it's also, performance monitoring is related to your system usage, which includes CPU, RAM, disk usage. Application or load balancer performance monitoring would also come under that. So that would include number of successful requests or failed requests, the latency of requests, and they're really good when we get to alerting. So usually when you drive your alerts, you're looking at the metrics that you've surfaced from your previous log collection. You might want to look at the time that a request takes to service. I find that that's typically a really clear early warning sign. So you can get a base level for what your system runs at, and then when you see latency going up, maybe your database is becoming less available. It's a really good early warning sign, but you need to look at what your system kind of performs like as a baseline and work off that. Your complete logging and performance monitoring solution might also be an individual tool for everything, or it might be a lot of separate tools that do very specific things. Yeah. Next, we're going to cover incident response plans. So these should be just a formal document that you have. They should contain information about who should be contacted when there's an incident in progress. It should mention who should be managing or overseeing that incident. And when you're, I don't know if anyone in this room has been managing incidents before, but you don't want the person who's doing the technical work to be the person managing it or managing like communication with the public. They're going to be like busy fixing the problem, so you want to have a non-technical person overseeing it. In your incident response plan, you also want playbooks, so have a think about what could be going wrong with your environment and just put together some scenarios and figure out what would happen and what the responses should be. You should also think about acceptable response times. Some companies prefer to have people specifically on call. Other companies are a little bit smaller, so there's only a couple of developers that are responsible for the server environment, and it's a little bit unrealistic for them to be on call 24/7. So you might want to say, hey, for this type of event, it's acceptable that like you might take 8 hours if it's the middle of the night for the person to wake up and then do the work in the morning. It all depends on what's acceptable to your company and planning around that. Speaking of, on-call plans. So on-call plans should include the person on call. It should include who issues should be escalated to, what kind of availability you expect people to have, on-call hours paid for, and this is really important as well if you expect people to, say, remain sober for for the on-call hours, and if you're saying, oh, just whenever a server error pops up in Slack, you know, go and fix it, well, that person can never be unavailable, potentially. So it's definitely worth thinking about. So far, we've talked about CI/CD, automated tests, monitoring and alerts, logging, incident response plans, and on-call plans. I'm sorry that this is so dry, but there's a lot to get through, and I wish I could be a little bit more specific over each one, but we'll see how we go. I'm going to pick up the pace a little bit again, because we still do have a lot to go through. Auto-scaling. So usage on your production system won't be consistent. This is the Steam game stats, so how many people are playing games on Steam. It's public. And it's just an example that on the weekends, there's more usage. When America wakes up, because there's a lot of people that use Steam in America, their usage spikes. So there are more people playing your game, so you need to provision more servers for that. But also, equally importantly, you need to scale down in these quiet periods where there are less people using your service. You don't want to just provision for peak usage and then leave it, because you're gonna waste a lot of money that way. Each major cloud provider has solutions for auto-scaling, and Kubernetes also implements auto-scaling features. So think about what you're deploying to and make sure that you do it. It's pretty standard. It's just a thing that needs to be ticked off like the rest of these things. Another thing to think about, which catches some people, is how fast you can scale up. So in the event that your game is presented on YouTube by a streamer or on Twitch, if you have a sudden influx of people, how fast can your servers spin up and respond to that? So that's worth thinking about too. Security updates. It's really not that uncommon for security issues to be reported for your tools that you're using, but also the libraries in your code. You should follow security advisory blogs. that are relevant to the libraries and tools that you're using when they're available. So bigger libraries and bigger tools will have specific security people that write like a CVE, and they'll tell you, hey, you should probably update, and they'll give you an idea of what the issue is and potentially what the risk factor is, that kind of stuff. So definitely go and find those as security advisories. They're a really good resource. There's static code analysis that discovers the libraries in your code base, and you can also monitor those libraries and get alerts if anyone submits a CVE. For Node.js, an example is Snyk, if anyone's used that, S-N-Y-K. But again, this is like so specific to the language that you're using, and it's extremely useful. So before you release, you should have a list of those security advisories to follow and have automatic monitoring solutions specific to your language, if possible. Security hardening is another thing that should be done. There's a lot of documentation out there specific to your language and your environment. For a couple of days' work, you can save yourself a lot of headaches with security hardening. You can also engage an external security contractor to have a look at your systems. If security is a priority for you, and by that I mean, do you care if your system is compromised, or do you care if it goes down because of like an application level denial of service attack? If those things are going to affect your company, you should probably have a think about security as an overall thing and engage someone who specializes in that. Because typically they're going to be more capable than your server developers. You should also think about backups. What happens if you ship a new update and your server code starts corrupting user data? Have a think about what type of backups you need. Is a daily backup enough for you? Is a weekly backup enough? Do you want point-in-time backups? Is it acceptable to roll the entire database back all at once, or do you want to be able to roll specific user content back? These are all questions you need to ask yourself and design a backup system to support your needs. You also need to test your backups. You really don't want the first time you go to use it to be when your database is no longer there or when it's been corrupted. Yeah, so please test them before you use them. Health checks are also good to set up. So load balancers use health checks. They're the thing where you go to an environment and you might have like /health. You can set up database requests in them so that you might want to test a read operation or a write operation to make sure that your database is reachable, or you might want to check some internal state. Very useful because your load balancer can avoid sending requests to unhealthy hosts. You can set up alerts using unhealthy hosts, and you can also, if you've got an auto-scaling solution that supports it, you can use auto-healing, which essentially cordons off a particular host and then replaces it with a healthy one. You should also do a bit of a permissions check, and this is super important for your cloud hosting providers. I don't know if anyone's used Google Cloud or AWS, but the permissions can be complicated sometimes. You should make sure that your servers have least permission. And by that I mean your virtual machine should, or your application, or your Docker container should only be able to access resources that you expect it to use. And the same goes for operations. If your application won't be deleting records, don't give it permission to delete records. So any operations that aren't normally used, make sure that your permissions are set up to restrict access. Also, a side note, if you pay attention to those permission exceptions and you alert on those too, you can potentially see if someone's doing something that they're not meant to on your server, which is handy to know. Compliance requirements, they're super boring, but your developers should be across them. They're not technically in the ballpark of server engineers, but you need to understand them. You've got a privacy policy. Any game that has that publishes to the Apple App Store is required to have a privacy policy, and you don't want to be putting in features in your game that breach that policy or be sharing your company information or like user data with third parties without putting them into the privacy policy and consulting with whoever's in charge of that policy. You also need to be thinking about personally identifiable information. You don't want to log or store any PII unless you really have a good reason to. But then also breach notification laws. So these are a big one that they're coming in with the EU and with America and even Australia. The laws around data breach notifications are getting a lot stricter. So you need to be aware of what your legal responsibilities are there. And that's more of a company thing, but you should definitely make sure that they're outlined somewhere. The other thing on the checklist that I go through is costing. So ideally, you want this to be per user so that you can times it by whatever your company wants to like launch at. So 10 million users, sure, all right, it'll be this much money per day. If your game uses REST requests, estimate how many requests each player will make in a session. If your game has persistent, stateful gameplay, so like a persistent server, work out how many concurrent players each game server will service, enter those numbers into a spreadsheet, and then multiply them by how many players you expect to have playing your game at launch, or even on an ongoing basis. Then do the same with data transfer. And from that, you should know how much resources you'll need to use. If you add in the prices from your hosting provider, you should have a pretty good picture of how much things will cost. And having it in a spreadsheet is handy because you can change the numbers around and you can see what 1 million users versus 10 million would look like from a cost point of view. We also want to test those documents that we just made with costing. So once you have your estimate of how much each player will cost to support, you can use something like JMeter if you're using REST requests, or you can use, if you're not using REST requests, you can use a modified version of your game client potentially. But essentially you just want to test those assumptions that you've made and make sure that your game's actually going to spin up to the amount of users that you're projecting for your launch. You also need disaster recovery plans, and backups kind of cover this. But this is like the documentation side of it. So if your hosting provider goes offline or if your database goes offline, what happens? So just make a note of the different situations that you want to be prepared for. You also need maintenance plans. They should include anything that needs to be done periodically. So for instance, you might roll some database records, or you might need to update your libraries on a scheduled timeline. So all of that stuff should go into your maintenance plan, and you should be building it as you work on your application. think that's pretty much everything, and I'm pretty happy because I got through it in 30 minutes. Sorry that I rushed through it. There's a link to the presentation if anyone wants the slides in the checklist. I'm going to check out the questions section so that we can go over that. We don't have any questions, which is good. Does anyone have a question in person?
With regards to maintenance scheduling in general and like taking people out of the app so you can roll the backup or something, do you have a particular approach that you've found works best, or?
Yeah, so having essentially a feature kill switch in your game would allow you to turn that off completely. And it means that the game itself won't try and perform those online like operations while you're trying to restore a backup. Yeah, so feature kill switches are super important for that. Yep.
Thank you. When you're doing an update to your app and you've got two different versions kind of out there in the wild at the same time, is there any clean way or smooth way of transitioning your user base from one version to the next version? Or do you kind of cold start the new version and say no one with the new version is going to interact with people with the old version of your game?
So there's two scenarios there. There's one which is a new version of your server which has breaking changes. In that case, you want a versioned endpoint. So sign in or create user /v1, that kind of thing. Yeah, so your new implementation of that with breaking changes would be on the v2 endpoint, so your old game client can still communicate exactly the same as previously. If you're talking about you want to maintain your player base all on the same version of the game client across the board, then you probably want major and minor versions on your game client. Your server environment could push that to the game client and say, this is my expected major version number, and this is the minimum like minor version number that I support. And then you can use that in-game to say, hey, please go to the App Store to update, or go to Steam, or yeah. Cool. Anyone else? Neat. Oh, one more?
Can you describe a little bit more about how you auto-scale? So you mentioned you use cloud provided tools, but do you use any ones in particular that you like, or?
Yeah, so I've had my most experience with Amazon Web Services. So in the case that you've got a persistent server on there, you can use Elastic Beanstalk. With Elastic Beanstalk, you've got a bunch of different things that you can scale on. So in terms of, you could scale on average CPU usage, you could scale on number of packets or bytes in, if that's relevant to your game. You can make a custom metric that you push server stats to, like number of free slots available, and you could scale on that if you want to. That would be with CloudWatch. You can also, with Kubernetes, set similar scaling parameters. So I believe you can set a container's average, you can look at your average CPU usage across each of your pods, and when it gets to a certain threshold, it'll spawn a new pod for you. That's with Kubernetes. With Google Cloud, I actually haven't used their auto-scaling features, but I believe that's part of the App Engine framework that they've got. If you're using like serverless REST endpoints, you don't super need to worry about scaling because they'll provision more infrastructure for you as you make more requests. Yeah, unfortunately, it's just really specific to the tools that you're using and the provider. Yeah. Cool. I think that's it. Thanks.